Let's look into the law of conservation of energy in mechanical energy. So what is that we're looking at? Well, first thing is first, let's talk about law of conservation of energy. If this, maybe something like this, let me do this. If this bubble represents all the energy in the universe, okay, there are different form of energy within this. Of course, I won't be able to draw all the forms or divide it into so many ways, right? Something like this. Okay, so what happens is, if there is a form, if this form reduces, say this will reduce, what happens? The other form will increase. Okay, if something else reduces, there will be some other form, so on and so forth. But this bubble will not increase or decrease, it will remain the same. There won't be any expansion of this bubble. If this bubble represents all the energy, then yes, this is true. There can be conversion of forms. This can get converted to occupying this many lot, right? A lot more than what it was initially. This can happen, but what cannot happen? The bubble can't increase. This is what the law of conservation of energy tells. Now applying to the scenario of mechanical energy. If this represents mechanical energy, okay, what happens? It is divided into potential energy and kinetic energy. Okay, guys. So mechanical energy is a sum of potential energy and kinetic energy. So what does it mean? I'm sure you will be able to figure out by now. I already kind of gave the answer away, but let me explain it with the help of a scenario which we can relate to, an object falling. So we have an object of mass m at a height of h with the initial velocity of how much should I take? 0, obviously, right? We're just talking about an object being dropped from a particular height. So the potential energy is obviously mg, g being the acceleration due to gravity, and at a height of h. Kinetic energy obviously is 0, since we know the sum of these two is equal to mechanical energy, so this will be mgh. So as per our basic idea of law of conservation of energy and the definition of mechanical energy, this object which is falling, which will begin to fall from this particular point, it's not being, it's in vacuum, so there is no buoyant force, there is no frictional loss or any kind of loss. So the mechanical energy by the end, before it hits the ground, right? This is just before it hits the ground. What happens? Nothing happens. The mechanical energy will remain the same. But as per our definition, the potential energy should be equal to 0 just before hitting the ground. Is it not? Because it's almost at a height of 0. What happens to the kinetic energy though? What happens to the kinetic energy? Right? See, this is 0. This has to be fixed. 0 plus what will be equal to mgh? Yes, 0 plus mgh is equal to mgh. Okay, 0 plus mgh will be equal to mgh. Make sense? So what does it mean physically now? It means that the potential energy got converted to kinetic energy as and when the object fell. Again, I'll repeat, the potential energy got converted to kinetic energy as the object fell. Okay, so let me talk about this in different form, two different forms again. So one, I just explained it kind of theoretically. I'll explain it numerically and we will see it as well. So how will I show it? Just give me a minute. I'll explain this and show it to you guys. So what is the physical meaning? An object that is free falling from a height will have the same energy throughout its journey. Just that the potential energy gets converted to kinetic energy as the object falls. So basically the mechanical energy is fixed. So at the top we have the object. Obviously the potential energy is clearly mgh. In between something happens. At the bottom all the potential energy gets converted to kinetic energy. If I pick up a particular scenario, okay, so we have a scenario. Let me just give me a second. Okay, I just changed the flow of it. So we are picking up a particular example and dealing with this. Okay, so we have, this is the example. So an object at a particular height of 10 meters with a mass of 10 kg, it's falling towards the ground. At the top, what happens? The mechanical energy is fixed. So let's talk about let me change this also actually. Let me change this as mechanical energy. So I'm going to change this as mechanical energy. This is kinetic energy, potential energy. Okay, now it will make a lot more sense. So potential energy is mgh 10 into 10 into 10. So 1, 2, 3 zeros. So many joules. Mechanical energy is 0 because the object is just left. We can see that it's not falling. Kinetic energy. Mechanical energy is 1000 itself, the sum of these two. At the bottom, what happens? Mechanical energy cannot be anything. It has to be 0. Here too, it has to be not 0. I'm so sorry. It has to be 1000 and 1000. Mechanical energy cannot change. Whatever the object started with its journey, the same energy will remain throughout its journey. While the potential energy just before it hits the ground is 0, right? Moment before it hits the ground, it has to be 0. Close to 0. So where will this energy go off? It will get converted to kinetic energy. Now, in between, somewhere in between, exactly not in the middle, somewhere in between, what happens? Somewhere in between, right? This will be 1000 minus x. So where will this x go? It gets converted to kinetic energy, right? Exactly in the middle, this will be equal to 500 and this will be equal to 500. Okay, exactly in the middle. And just before it hits, or somewhere over here, this will be 1000 minus a very, very large value. Okay, so I think I'll do this x, and all of that will get converted to x over here. Let me make it something like this. Yeah, a lot more of energy is got converted to kinetic energy, and just before it hits the ground, all of the potential energy gets converted to kinetic energy. Okay, so this is what is happening. So this value will always add up to, these two values will always add up to whatever the mechanical energy is of the object at any moment of time. At any moment of time, mechanical energy is 1000, 1000, 1000. Potential energy is reducing, kinetic energy is increasing. Okay, so let's look at all of this in terms of a simulation. So first thing first, I will show you guys what is that we are dealing with. We are looking at what? Yes, a bouncing ball. Okay, now let's visualize this in terms of mechanical energy and kinetic energy. Let me open both. Now, what's happening? At the bottom, you can see at the peak, you can see the potential energy increases. At the bottom, the kinetic energy increases. Right? So please match it. I'm not able to tell it. I made it too fast. So you can see that, right? At the bottom, you can see potential energy becomes 0. Kinetic energy increases. As in when the object is going up, potential energy increases, kinetic energy decreases. Can you see that? So this is your potential energy, this is your kinetic energy. Please observe. Okay. Now, look at the mechanical energy. What is happening? Mechanical energy, nothing is happening other than the color change. The height is not increasing or decreasing. But the color is changing. What does it mean? Well, the contribution of potential energy and kinetic energy is changing. Right? Just at the top, in entirety, it is mechanical energy, is potential energy. And at the bottom, again, when it comes, you can see at the bottom, we can see it becomes kinetic energy. The entirety, mechanical energy in entirety is contributed by kinetic energy. Okay, now please make your observation. Let the idea sink in. Again, all of this, you guys can also simulate. You guys can also do all of this. You can change things. You can make the values to be different, right? All of this is available. Will be made to you guys will be made available to you guys. Okay, right? So I hope you guys understood, and hopefully we'll be able to do the numericals which we were not able to do before. Right? With this, we will be able to do a lot of questions. Is it not? So let me just complete this. So this entire thing represents mechanical energy. This entire thing represents the energy in the universe. Energy in total. Okay, so physical meaning is this. I guess this you guys can write. This one you guys can write as an example in the next, whatever it comes over here. Physical meaning. right, and the example and so on and so forth.